I'm just going to share the screen of what we have prepared for today's lecture. And I must tell you today, the Zoom application is having some kind of a trouble. So in case, in between the lecture, if you are not able to listen to me or if my video is not clear to you, you can just leave the class. We shall send you as usual the recording for this. Okay. So I don't know what's the trouble was that, but till now everything is working fine. But still in case some trouble is there, so recording will be there. So again, before sharing the screen, I would like to take your quick confirmation. If my voice and my video is clear to you, can I get reply? I just need 2 or 3 more confirmations. If my voice is clear to you, all right, I have got the confirmation. Thank you so much for that. Now I'm just going to share the screen. And I'm going to tell you what we have prepared for you in today's lecture. All right, I'm just going to show you what is there in this lecture. This topic is very important from exam point of view. And we have already covered a lot of things regarding paper 1, research. And this topic particularly relates to paper 2 only. Okay. It doesn't mean that probability is a 0 for paper 1. The questions to be come from this particular topic, but still there are very lesser chances that in paper 1 this question can be this specific topic questions can be asked. So this was the reason why a message was floated in your WhatsApp that there shall be no class for paper 1, because I do not want to burdenize the students of paper 1. Specifically, this is for paper 2, and this is irrelevant of any specific subject. Okay. This topic for paper 1 relates to any stream, whether you are belonging for commerce, management, or any subject, economics, or any subject, because research is always there in the paper second as well. For this is the reason this topic is very important for you. And let me tell you very clearly that you shall be able to understand this specific topic only if you have understood about the basics of a hypothesis. Basics of hypothesis. Okay. And after that, most importantly, the normal distribution. Normal distribution. If you have understood about that, only then you shall be able to comprehend the topics and meanings of these specific tests. Okay. Probability of a question being asked from Z test is lower in comparison with the probability of a question being asked from F test. F test directly relates to Anova. It directly relates to Anova. And if you go through from the previous papers, very simple kind of questions have been asked from F test or Anova. Okay. So you just have to understand what I am telling to you, and after that everything shall be clear to you. Okay, now just a quick recall of everything you have understood in the hypothesis testing. I hope that you got 2 holidays, and those holidays you would have gone through repeatedly from the hypothesis and a research video lectures, and only then you shall be able to comprehend this specific topic. I taught you about population. Population is there. A population contains a number of elements, and if we find any kind of value regarding the population, this is known as parameter. This is known as parameter that I taught you. And this is a sample. Sample is always taken from the population. That simply means the sample is the part of the population. And if you find any value, any statistical value or measures of central tendency, then dispersion or anything, then this is known as a sample statistics. And research is always done on statistics. Okay, and after research is done, after the hypothesis testing is conducted, the specific tests named t test, then z test, then f test, chi-square test, these are applied. I taught you that after finding the specific statistics, you get a value. Okay, you get a value, and this value is known as observed value. Observed value. And after that, you have to compare this observed value with the critical value. Where is this critical value? I taught you that this lies in the tables of the respective tests, like t test, z test, f test. Each test have its specific tables. When you have found the observed value, you have to compare this observed value with the critical value, and on observation you get to know the decision regarding acceptance or a rejection of null hypothesis, and it exactly tells you whether you were right in your hypothesis or not. So this was the complete overview of what we have learned. In the t test we did that this is used for small samples hypothesis testing. Small sample simply means where the size of sample is lesser than 30. Okay, so that is small sample, and only t test is applied on small samples. Now we shall be talking about large samples and small samples with some certain characteristics as well. Okay, so now we move further. We have to learn about the basic concept of z test and f test. I hope you would have listened to this specific slide very carefully. Only then you shall be able to understand the upcoming slides. So this is about z test. Okay, so normally this is also known as normal distribution test. Some author also name it as normal distribution test. So by name you would have understood this completely. And this is used for a very specific purpose, just for the comparison of correlation coefficients of small samples. So this is just a very simple history of this. Like R.A. Fisher was the first person who devised this specific test, and this is used for finding the significance of differences between values of correlation coefficients. Now I'm just giving you a very simple example, and after that you shall be able to understand why this test is applied. So this is a complete population. Okay, this is a complete population. From this population we have found two samples. Okay, this is sample 1 and this is sample 2. Suppose we have found two samples. Okay, when we have found two samples, then we try to find their correlations. So this is correlation 1 that belongs to sample 1, and here is correlation 2nd, and that belongs to sample 2nd. And if a researcher says that there is no difference between correlation 1 and correlation 2, for comparing these correlations, the test which is used, that is known as z test. So this is all about z test. I hope you would have understood that this is used for making the comparison of correlation coefficient, and this is used to find whether the correlation of two samples differs in respect to each other or not. So this is the complete description of z test. So this has been formulated by R.A. Fisher based upon transformation of a correlation coefficients into Z. Okay, when you find a correlation coefficient of different samples, these are denoted as Z. So this is the reason why this test is named as Z test. So this is a standard normal variate. Okay, this method of testing is also known as method of Z transformation. This is also known as that. Okay, so what I have taught you, this is very simple. Just find two samples. Okay, after finding two samples, you have to find their individual correlation, and when you have found their individual correlation, you have to make the hypothesis that there is any difference between correlation 1 and correlation 2. This is your hypothesis. And for proving this hypothesis, the test which is used as, this is simply known as Z test. And this is also known as Z transformation. And this was given by Professor Fisher. So this was all about that. Now only formulas are left, and these have been clearly written in the notes as well. What you have to do, you have to learn, or you can cram as well, because they can ask you the individual formulas as well. Okay, so I think only one or two formulas are there for Z test which you have to go through, and do not solve any kind of numericals, because these shall never be asked, because its numerical are very huge. They can take the length of 2 or 3 pages, and the people are sane enough that they are not going to post any kind of practical. So this was the concept matter regarding Z test, and now you have to understand about why the Z test is used. Okay, so under this method, the significance of difference between an observed value of R and a hypothetical value of R is comparison. Okay, so comparison is made between the observed value of R. What is R? R stands for correlation. The smaller r stands for correlation. So here it is tried that the significant difference between observed value and hypothetical value of r is comparison. So first example, I told you that you can take two samples, sample 1 and sample 2, and you can find their correlation 1 and correlation 2, and you can simply make the comparison of these two, and you can find an observed value, and you, after finding the observed value, you can compare this value with the critical value given in the Z table. Only then you can find that whether there is a significance difference or not. Okay, so this is the first example. Second example I'm going to give you, this is a complete population. Suppose you have not taken two samples, you have taken only one sample. This is sample 1, this is population, this is sample. Okay, you find the correlation of a population and you find the correlation of a sample. You can also make the comparison of a population correlation with the sample correlation. So this can also be the way for using the Z test. So this is all about the Z test, I think. This, and it is also used for making comparison between any two independent correlation coefficient that is tested by appropriate Z statistic. Z statistic you would have understood by now. Okay, what is Z statistics? When you have find at least two correlation and you make their comparison and you apply the formula. After applying the formula, what you get an observed value, and that observed value is known as Z statistics. And that observed value or Z statistics is comparison with the critical value given in the Z table. Each and every test has its own table. You can see that table in the notes as well, and you can see that table in your undergraduation and post-graduation books appendix. Okay, and in the last pages of your statistics books, you would have sometime seen that there are number of tables attached. So these are known as different tables for different tests. So this was all about Z test. I don't think there is anything else remaining for making this concept more clear, because practicals we are not going through, and the concept and subject matter is necessary for understanding these tests. Probability of Z test being asked in the examination is lower. Even if this is asked, that was sufficient, but you have to understand and remember the formula for Z test. So now I'm just going to move further with the F test now, and I'm going to teach you the complete subject matter of this. Okay. So what is F test? Okay. So why this is used? Again, a simple, a very good example. I think this slide is somewhat empty, so I'm going to write here. After that, I shall be reading all these things, so you can easily understand what's that. Okay. So the one word is F test and the second is Anova. Students feel that these two are different things and they are very dangerous, but these are not the case. These are very simple to understand. I must tell you. Okay. First, you have to understand about this, and after here here comes the turn of F test. F is not a dangerous word. This is just a first letter of the name of R. Fisher. Okay, because he gave this specific test. He propounded this test. So what is ANOVA? ANOVA is simply an analysis of variance. Analysis of variance. Again, very simple example. You will be able to understand complete subject matter. Here is a complete population. Okay, you take two samples. This is sample 1, this is sample 2. Okay, sample 1, sample 2. You find their variance. Variance you would have understood when we taught you about measures of dispersion, or you would have understood in your graduation or post graduation. So just keep a population. After that, you have to find two samples, sample 1, sample 2. After finding the samples, just find their variance. That will be variance 1, that will be variance 2. And make analysis of these variance only. This is very simple. In Z test, what I taught you, take two samples, find their correlation and make a comparison of these by Z test. Okay. In this, I am just going to tell you in case of ANOVA, just find two samples. After finding two samples, just find their variances. That will be variance 1, variance 2, and you have to make the comparison. And after making the comparison, you get an observed value. You get an observed value again. Okay, you get an observed value and you have to compare this observed value with the critical value, and where this critical value is given, this value is given in F table. This is why this is known as F test. Otherwise this do not have any specific kind of logic why this test is known as F test. So this was all about that. Nothing difficult to understand. Okay, what is this? You have to find at least two samples, sample 1, sample 2. After that, you have to find their variances. That will be variance 1, variance 2. And after that, you can just compare these two. You have to apply the formula given in the given for the analysis of variance. After applying the formula, you shall get an observed value. When observed value is found, you have to compare this observed value with the critical value, and this critical value is given in the F table. The reason why this is known as F test. So this was all about F test. I think the only thing you have to understand now, the only extra thing is this: the analysis of variance is not restricted to two samples only. Okay, this is a population, this is a complete population. This is sample 1 and sample 2. I have given you example of two samples, but analysis of variance can be found for more than two samples as well. So there can be sample 3 as well. What you have to do, you have to find variance 1, then variance 2, then variance 3. There will be 3 variances. And suppose there are 4 samples. This is sample 4. Then there will be 4 variances. There will be 4 variances. Okay. So only this is the thing, the formulas changes. Otherwise, everything is same. Okay. So this was about F test. I'm going to tell you now what has been written, and everything shall be provided at your doorstep. So analysis of variance can be defined as a statistical measure that analyze the variance. Okay, analyze the what? Analyze the variance of two or more comparable series or samples through F test. technique to ascertain whether the difference in the mean values is significant or not. So this is the case only, okay? And whether different samples under study are drawn from same universe or not, okay? So this is not the case to very difficult, okay? This is simply saying that after making the comparison of two variances, you get to know that if there is any difference between their mean value or not. You are not supposed to find their mean value, okay? Only variances are enough. Just by making the comparison of variances, you get to know whether there is a difference between two samples or not. This is the case only, okay? Well, and you get to know that whether these two samples belongs to same universe or not. That means belongs to same population or not. So this is the F test concept. In this slide, it has been written its characteristics, like it makes a statistical analysis of variance of two or more series. So this is done in the analysis of variance. What it does, this make the analysis of variance of two or more series or samples. So this is done in that. The second is it determines whether there is a difference in the mean values of a different sample is due to chance or anything else. Okay. Don't. So what we have to do is simply to find the value of variances of two samples, and we can easily compare these two values. And once these are compared, then you can get to know, is there any difference between the samples or not. Only this is the concept of the F test or analysis of variance. You are not supposed to be bothered about mean values. These are automatically defined when you find the variances. Okay. After finding the variances, what you have to do is to compare these two variants only by applying different formulas. So this is the concept of F test. So this was the second characteristics. Now we move further. So this says that it gives the desired result by finding the appropriate variance ratio through F test technique. Okay. So F test technique have a specific table named F table. Okay. And once you have found your ratio of different variances, you have to compare this ratio with appropriate variance ratio, and that is given in the F table. The next one is it is assumed. So there is some assumption regarding F test. So it is assumed that the sample are drawn from the universe, and this universe is normally distributed. Universe means a population. So this population is normally distributed. So this is the assumption of F test or Anova, analysis of variance. And the second is it is also assumed that the samples are drawn at random and these are homogeneous and independent to each other. So this is the second assumption for the analysis of variances. And the third one is it is also assumed that there is no difference between variances of different universe from which the samples have been drawn. Okay. Suppose there are two populations and we have to compare the variances of these two populations. And the first assumption is made that there is no difference between the variance of population 1 and variance of population 2. This is the third assumption of Anova. It is saying it is assumed that there is no significant difference between variances of different universes from which the samples have been drawn. And the fourth, it is saying it starts with the null hypothesis that V1 is equal to V2 is equal to V3 and so on. V stands for variance 1 is equal to variance 2 is equal to variance 3 is equal to variance n. So this is the null hypothesis, which is saying that there is no difference between variance 1 and variance 2, variance 3 and so on. So the next is its assumption, and this is very obvious as well. You have to compare your observed value with the critical value, okay, at a specific degree of freedom, which we have already understood. And this table or critical value was given by Senedisar. So this was the name of person. He, along with Fisher, they propounded this specific technique of analysis of variance. So its last assumption is that the critical value of variance ratio is estimated by uh, Senators are for different degrees of freedom, and you have to compare your values with this value. So this was the fifth. So now here is some detail or some history about F test. I think it's time for it to come. This is statistical technique which provides for testing the significance of difference between observed value and estimated value of the ratio of a certain variance. So this is about F test. This technique can be used for analysis of variances of two or more than two samples in which other tests cannot be applied, like Z test or T test. Okay, in which these tests cannot be applied, there the F test is applied for finding the analysis of variances. Then this technique was developed by R.A. Fisher in 1920 in collaboration with his colleague Senedisar, who gave the table which is known as F test, and the word F stands for Fisher. So this was about its history. Simply written that the letter F in the name Fisher. So this is called F ratio table or F statistics. Then we have to move further. There are some steps to find F test technique. Okay. What are the steps for finding the F test, F ratio, or the analysis of variance? Analysis of variance. Remember in your mind that I have taught you that if there is a population, you can compare the variances of two sample or more than two sample, like sample third or sample fourth or anything. Only the formulas changes. Only the formulas changes. Otherwise, everything is same. So first, what you have to do, you have to take null hypothesis that there is no difference between mean values or the variances of the different samples. So this is the first step. In the first step, you have to state the null hypothesis. This is variance 1 is equal to variance 2 is equal to variance 3 and so on. So this is the first step which is telling you to state the null hypothesis. In the second, you have to find the variances of different samples. This is the formula. Clear-cut formulas have been written in the notes. You have to find the sample variances. Okay, variance. If there are only two samples, okay, so this is a population. If there are only two samples, the formulas are very easy. This is variance of one, variance of second. Okay, but in case if there are more than two samples, then three kinds of variances you have to find. Three kinds of variances. Okay, and what are their names? The first name is variance within the sample. It has a separate formula. The second is variance about the samples. Okay, so this is the second type, and the last is variance among the samples. So this is the third type. What I have taught you, if there are only two samples for our study, then these formulas are very easy. This is variance 1 and variance 2. But in case the samples are more than 2, 3, 4, 5 or anything, then you have to find three kinds of variances. Three kinds of variances. The first is variance within the sample. The second is variance about the sample. The last is variance among the sample. Each and every kind of variance has a different formula which you have to remember. It has different formula. Okay. So in the second step, you have to find the variances. Then what you have to do, you have to construct the Anova. You have to construct the Anova from the different kind of variances, and you have to find the observed value. That means you have to apply the formula for finding the observed value. Okay. So this is known as the process of constructing the table of analysis of variance. Then after that, simply what you have, what you have to find, you have found the you observed value, you have to find the estimated or critical value from the F table, and you have to write it some at some place. Okay, and for finding that, you have to use the concept of a degree of freedom at a desired level of significance. And after you have find, you have to compare the observed and critical value. Okay, so there is observed value which is known as F only. Okay, if your F value is greater than critical value means table value. If your observed value is greater than critical value, then we shall reject the null hypothesis and we shall tell yes, there is difference. There is a difference and we were wrong in our hypothesis. Okay, what hypothesis we made? We made that there is no difference between variance 1, variance 2, variance 3 and so on. We made this null hypothesis. But in case the F value is greater than critical value, you have to reject the null hypothesis and you have to state that your hypothesis is wrong. But in case the F value is lesser than the critical value, then you have to accept the null hypothesis and you have to state we were right in our decision. We were right, and there is no difference between variance 1, variance 2, variance 3 and so on. So this was all about the concept of F test or analysis of variance. I hope you would have understood this completely. Otherwise, only formulas are left, and each and every subject and concept matter of this has finished by now. So this was about the Z test and F test, which you must understand. The probability of question being asked from F test is greater than anything else, but T test is also important, but Z is comparatively lower important, but you have to go through. I suggest you to read and remember their formulas which have clearly been given. You are not supposed to solve their practical. So in this way, I have taught you completely about the yesterday's tomorrow's lecture. We shall inform via WhatsApp, and I must tell you the new scheme for attempting the video lectures test via YouTube videos are being conducted from now onwards. That shall be delivered to you, and that contains not only the paper 1 test but the paper 2 test series as well. And you have to be very regular with that, and we can take your test at any time. I can call you, I can ask about your preparations. So this was Gurpal Singh from Gurpal Education. Thank you so much for listening.